Hello everyone. In this video I will show you how to create a soil file for use in the DSAT crop modeling software. So soil information is crucial for simulating crop processes. So DSAT has already extensive database built in which can be used for general simulation purposes. However, if you want to define your own experiment, these soil profile descriptions are you need to add some your own soil profile. So the we can easily add experimental soil data into the soil database and can be used to run the experiment. So basically you can go to the DSAT, open the DSAT folder here, open sorry DSAT, and then if you go here, click on the soil, then you will see the soil extensive directory here. So for general soil profile you have to go into the soil.sol, you have to click here and you will see the all the soil profile here which are already available in the DSAT. So now I'm also going to show you through the directory that how you can see this. Just go to this directory DSAT and then you go to soil, and here you have to go to the soil.sol. remember you have to open this one, soil.sol file. If you open this file, so there you can see, here you can see the different soil profiles. So what does it represent? Now let's have a general look here. So basically soil file naming convention. So first of all, soil.sol is your file which you have to open. You can see the .a is your institute identifier, and then soil profile naming, how we name our soil profile. So basically it consists of total 10 digits. The first two digits represents your institution identifier, the second to BB site identifier, the two next digits YY means your year of data collection, soil data sampling, and the last four is your profile number. For example, this is an example written here. Let me open one, soil Kalamazoo soil. So you can see here this MS means the institute identifier, and the second two digits KB is your site identifier, and the second two digits mean YY means year 89, and the last is your profile number, and this is your general soil name. So basically let's have a look at the, this is your metadata, the first four columns, and then this is your surface properties, and then this is your profile properties. Let's go to this here. So you can see here, this is your metadata, this is your surface properties, and this is your soil properties. As I told you, this is your profile properties here. So let's go to the DSAT and select how we can open this. Even you can open here, you can click here, click on edit, you can open a particular file. So this will open a SBUILD where you have to make your file. So this you can see here, its country is USA, Gainesville. So UF you can see is the site identifier, University of Florida. GA stands for Gainesville. 01 is the year 2001, and 700 is the profile number. So must have latitude and longitude for our soil profile. This is the soil series name. So the color was yellow, the top layer color, the slope percentage slope, the runoff potential was the lowest. Moderately, you will see some description here also, and the fertility factor, drainage. If you click on next, so input table, you can see the depth. So master horizon, these are not necessary, -99, that these were not added into this here. So here you can add the clay percentage, silt percentage, stones. You don't require, if you don't have, you put -99 here. Organic carbon percentage, pH in water, cation exchange, C mole per kilogram, total nitrogen in the soil layer. If you click here on the more inputs, you will see that these are some more information required, which right now we don't need, but in the next and later on, if you need, these are your important, you can add here, and then you can press OK here. So if you want to add layer, you click here, otherwise you click next, and then it will show you your runoff curve number, albedo, drainage. The important lower limit means your lower drainage capacity, drainage upper limit, saturated water content. So lower limit means the wilting point, permanent wilting point, drainage upper limit, saturated water content, bulk density is gram per cubic centimeter, saturated hydraulic conductivity. If some of are available, you can find out the remaining by clicking here on the calculate missing values. So just click on finish, it will finish here. Now in here you have to be careful that, so now if you want to close this, if you want to already available, this is already available, we have opened the soil file already available in the DSAT. If you want to close it, first you have to click close the profile here. If you want to save it, if you put edit anything here, you have to click save, then you press close. First close the profile, so you will see the warning message that you are about to close. Are you sure you have saved the changes? Press yes. In this case we haven't made any change here, so then after profile, then you have to close the file. So yes, I have done yes, and this, in this way you can close your DSAT file. So file and exit, then you are back to your DSAT. And even I have shown you at the directory how to approach this one by going to your DSAT directory in the C drive and going to soil and open the soil file. You will see here the different files here. So now let's back. Now I'm going to make a soil, click on the soil data, SBUILD. You want to build an SBUILD. Okay, so press OK here. So now let's first click on the profile, new. So this window will appear for you. So I have a general already file available with me. Just I want to show you how to add these details here. So the for country, let's say I have already here India file here. Site name is Umaria. Institute code, you can put any institute code here, and let's talk about the latitude here. So institute code is compulsory. You can add institute code has or whatever is the 2-digit we need, as I already show you here that you need 2-digit. First digit would be site identifier BB. So it's up to you, whatever you enter. You can add here has let's say latitude. So I'm going to add latitude here. So let's start here with the latitude, entering here. So we need to enter into the decimal 23.5, and then click on longitude, it's 80.75. So the top color of the soil is, let's say, brown. And soil data source, what is your data source, what are the soil series name, soil classification. So soil classification, let's say it was fine, hyperthermic, vortic, soil series name. You can add soil series name means either it is loamy or sandy soil, what kind of a soil you have here. So let's add the soil name here. Series name here as sandy, clay, loam. So drainage is what we have already available here with me, is a general file. You can add your own data here, what according to your own observations. So percentage slope we have to add, let's say it's about general slope 1%, and runoff potential is lowest. Fertility factor 0 to 1, you can add from 0 to 1 any value here. Fertility factor for very slight erosion we can say here, and the drainage, that is, so we will call it as a well drained soil. So then click on next. So you have to add here by clicking on add layer. It depends how much layers you have, you can add multiple times here. Add how much layers you have to what extent you have done this data. So I have, let's say it's the first layer was 0 to 11, so I will add here 11. So and then next layer was 31, from 0 to 11, 11 to 31. Centimeter depth, remember this is a centimeter, we have to be careful with our units here. So then 31 to 50 centimeter, and then 50 to 75, and this is again, I don't have any minus 99 here. So clay percentage 24.5, 36.4, 43.3, 48.2. So similarly, silt percentage, so the last up to the 75 centimeter depth we have the silt percentage 12.9. In case if you have a stones percentage, then you can add, otherwise you can add minus 99. Organic carbon percentage, remember this is we have to add in a percentage, so 0.97 in the first layer, 0.66, 0.5, 0.4. pH in water 6.7, 6.4, 6.4. So CEC cation exchange capacity, that's unit is C mole per kg. If you don't have you have to first convert the unit into C mole per kg. So total nitrogen percentage, if you have already total nitrogen percentage you can add, otherwise you can leave it as it is. Then more inputs, if you have already more inputs available, phosphorus, isotherm, calcium carbonate, aluminum and potassium, exchangeable C-mole, nitrate, adsorption factor, if you have these factors you can add, otherwise you can leave it as it is. Let's say I have a calcium already exchangeable 11.3, now also potassium available with me, press OK, click on next. So let's suppose if you have this runoff curve number is automatically calculated, albedo 0. If you don't have this lower limit, drainage, upper limit, water content, bulk density, you can click on, otherwise you can add these values here, otherwise root growth factor, you can click on calculate missing values, it may automatically update it for you depending upon the So depending on these factors you provide in the background. So these calculations are based on Sexton and Rawls method as described by Gisman et al 2002. Remember, this is all the scientific method. So then you will click on press on finish. You will move back to your first page, so soil data source, and then you will click here on file profile. First you will click on save. So then you have to give the profile number. So remember, this is the institution code. The first profile name starts with the institute code. It can be general information section. So these here, it will be your 10 digits total Umaria, and then the site would be, you can say, has, it could be any university or whatever. It's, let's say I say it's any valley here, VA, as I already show you here. So the first digits institute identifier, site identifier, then the year and the profile number. So let's go back to your, then we have add 2 digits. Let's say it was conducted in 03 2003, the last 2 digits of year, and then the 4 for profile number. So you can add like 0003. Let's say, just an example, press OK, it will be saved here. So now you just close first this one, yes, and then you have to save file, and then you have to close this here. So then exit here, and then we will go back to our directory soil.sol. So now here you can see at the last your file will be created. You can see here this was the code. 03 means 2003, site identifier. This one is your institute identifier, site identifier, year, and the profile number. So sandy clay loam, this is the general, and then these are your soil profile. So I already, so in this way you can see here, like these are include the metadata, surface properties, and soil profile properties. So here these are your soil profile properties. So at the end you have to see, let's say if you want to change, edit anything, you can also edit here. Like for example, by mistake I added soil organic carbon has 97, but it can be added here like 96, you can add here, and then you have to save this file, and then you have to close it. So now you, in order to see your soil profile, again you have to go to the update all LST files. You will see option soil LST files here. It will take some time to refresh the directory, and then just open any experiment. Again I'm going to open this maze experiment, and I'm going to edit this experiment. Click on edit, and then again if you open your experiment you have to click refresh. In order to, you have to do this for both weather file and soil file. So now you will go here, init fields. So you have to click here in under the soil section. You will find Omaria. So we can also look again what was the code here for it. Your newly soil profile will be at the end, remember, at the end. So UMVA is the code. So we have to look here, find our file here. So in this, let's talk about, we have made recently the new soil file with the name Umaria here, and this is, you can see the code for this one, and the name by from which you can search is, it's sandy clay loam. So just go back to your DSAT, and we just open any experiment and go to the fields, and then you can search here clay, sandy, it starts from sandy, S, sandy clay loam, this go. So you can see here that it is soil.sol. So just click here, you will find the code, same code, it should be the same code. So in this way you can find out for where you have made recently. So just close this file. I want to show you something. Just go to the data, soil, and here you come back to the soil.sol. Even you can go from the C directory, DSSAT drive, and then go back at the last. If you want to make some edit in it, you can just right click here, edit the file, and then you can see the soil series name sandy. Whatever name you enter here, you can search it from with the name and the code. So this is all your, if you want to make some edit here you can go, but remember, first go to profile. If after making any changes here, save it, then go to file, save it, then close the profile. Yes, I have already made the save the changes, and close this file, close. Okay, in this way you have done how to make the soil file from the in the DSSAT with the SBUILD. And if you want to go more, you can search for the other files also already available in this one. So thank you for watching. I will post the link and for the DSSAT and for any information below here, and I will share the link in the description. You can check there more information about it, and if you have any question, just comment in the comment section. Hopefully you enjoyed the video. Thank you very much for watching the video.